Hello friends, a very warm welcome to the discussion of another topic pertaining to CSAT examination. Today's topic is LCM and HCF, that is least common multiple and highest common factor. Although questions are asked on this particular topic per se, but apart from that, LCM and HCF, they play a pivotal, very important role while performing calculations in the questions pertaining to other topics. So let us know the basics, the concepts and fundamentals, and the methodology for solving such questions. Now, first of all, let us know what is LCM, the full form of which is least common multiple. Now, the LCM of n numbers is that smallest or least value which is completely divisible by each of the n numbers. Now, let us take two numbers, 20 and 25. Now, you have to find out the least smallest number which is divisible by both 20 and 25. So as to say that number should appear in the tables of both 20 and 25. And out of all such numbers which appear in the tables of 20 and 25, the least out of those will be the least common multiple of 20 and 25. Now here the LCM works out to be 100, as you can see here. We will also learn how to find out the LCM. But as of now, you know that 20 into 5 is 100 and 25 into 4 is 100. So 100 is that least number which is divisible by both 20 and 25. There is no other number lesser than 100 which would be divisible by both these two numbers, 20 and 25. Then what is HCF? The full form for HCF is highest common factor. In LCM, we were talking about a common multiple, and here we are talking about a common factor. Now, HCF of n numbers is that highest value which completely divides each of the n numbers. Let us take these two numbers, 20 and 25. Now, which is the highest number which will divide both 20 and 25? Now, you know that factors of 20 are 1, 2, 4, 5, 10 and 20, and factors of 25 are 1, 5 and 25. So now, out of these groups of factors, you know that 5 happens to be the highest number which will divide both 20 and 25. Beyond 5, we have 10 and 20. Beyond 5, we have 25, but nothing else is common here apart from 5. So 5 happens to be that highest common factor which will divide both 20 and 25. Now, coprimes. The concept of coprimes is very popular. The concept of coprimes will be used very frequently while solving questions based on LCM, HCF, or solving questions based on divisibility rules. Now, what are coprimes? Two numbers such that their HCF is 1. The highest common factor between two numbers should be 1. In other words, the coprimes do not have any common factor other than 1. Well, every positive integer will be divisible by 1. But when we talk about coprimes, there is no other number apart from 1 which will divide the two numbers. So let us take some examples here. Two prime numbers, or maybe more than two prime numbers, will always be coprimes, like 13 and 17. Now the factors of 13 are 1 and 13. Factors of 17 are 1 and 17. So the highest common factor here is 1, which is common to both. 13 does not divide 17, 17 does not divide 13. It is only number 1 which divides both 13 and 17, and that is the highest common factor. So two prime numbers will always be coprimes. Second, two consecutive numbers like 24 and 25. Again, 24 has lot many factors like 1, 2, 3, 4, 6, 8, 12 and 24. And 25 has only two factors, 1, 5 and 25. So 5 is not present anywhere here as a factor of 24 because 5 does not divide 24. 25 is a number greater than 24, so it obviously cannot divide 24. So the highest common factor or the highest number that can divide both 24 and 25 is 1. So any two consecutive numbers, 1,01,000 and 1,02,000, even that also, these two numbers which are consecutive will always be co-primes. Now a prime number n and another number m where m is not divisible by n. By that I mean 13 and 15. Now 13 is a prime number, 15 is not a prime number. So it is a composite number. What are composite numbers? Which are not prime numbers as of now. So because 13 has only two factors, 1 and 13, and 15, the other number should not be a multiple of this prime number 13. So it will have 1, 3, 5 and 15. So once again the common factor for these two numbers will be 1. Now fourth, two composite numbers. Now by the way, composite number is the one which has more than 2 or at least 3 factors, both being the same. So two composite numbers, now such as 25 and 27. Now 25, what are its factors? 1, 5 and 25. 27, what are its factors? 1, 3, 9 and 27. Now out of these again, 1 is the only common factor which would divide both 25 and 27. Although 25 and 27 are not primes, they are not consecutive numbers also. So such kind of pairs of composite numbers which have their highest common factor as 1 are also termed as coprimes. Now let us have a look at a question here. Find out the LCM of 10, 15 and 20. Now there are two methods that I would describe here while solving such questions. The first method that we will take up here is prime factorization method, wherein we will express each of these numbers as multiples of prime factors. So this is 2 power 1 into 5 power 1, that is 10. 15 is 3 power 1 into 5 power 1. 20 is 4 into 5, so that is 2 power 2 into 5 power 1. Now out of these, we will take the highest power of each of the prime factors, like 2. Now the highest power of 2 here is 2, so 2 square into, now the next prime number is 3. So 3, the highest power is 1 because 3 is seen only once in the case of 15. And the highest power of 5 is 1 only. So this becomes 4 into 15, which is equal to 60. So the LCM of 10, 15 and 20 is 60. Now here itself, we know that 2 into 5 is 10. So in these prime factors, wherever you find a 2 and a 5, take them separately. So I am going to combine one digit 2 with 5 here, so that we get 2 into 3 into 5 into 2. Now this is 2 power 1, this is 2 power 1, so anyhow this is 2 power 2, 2 square. But the benefit of separating 5 into 2 is that we know 5 into 2 is 10. So whatever we obtain on multiplying 2 and 3, which is 6, we just need to put 1 0 ahead of this. So instead of multiplying 4 with 3 and 5, you can simply multiply 2 and 3 to get 6 and put a 0 ahead of it. Now the second method, which is most popular and most easy to apply, actually is called the LCM method, in which you simply have to recite the tables. Go to the highest number out of the 3 numbers given to you. The highest number is 20. Now recite the table of 20, and then whatever numbers that you get in that table, see which out of those numbers is divisible by both 10 and 15. Both 10 and 15. There could be certain multiples of 20 which are divisible by 10. In fact, all multiples of 20 will be divisible by 10 because 20 is divisible by 10. But they may not be divisible by 15. So when we recite the table of 20, we know 20 into 1 is 20. But that is not divisible by 15. So 20 is out. Next is 20 into 2 is 40. Again not divisible by 15. So 40 is out. Next number is 60. Now 60 is divisible by 15, as 15 into 4 is 60. We know 10 into 6 is 60, and we know 20 into 3 is 60. So 60 happens to be the least common multiple of these 3 numbers. So these are the 2 methods which will be employed while finding out the LCM of given numbers. Now let's have a look at this. 18, 28, 108 and 105. Find out the LCM of these numbers. So let us express 18 as multiple of prime factors. So the prime factors here would be starting with 2. Is 18 divisible by 2? Yes. Is 18 divisible by the next power of 2? That is 4? No. 18 is not divisible by 4. So we get 2 raised to 1. Now next prime factor is 18 divisible by 3? Yes. Is 18 divisible by next power of 3? 3 square, which is 9? Yes. 9 into 2 is 18. So we get a 3 square here. Now that's how you can prime factorize. Looking at the next number 28, is it divisible by 2? Yes. Is it divisible by 2 power 2? That is 4? Yes. 4 sevens are 28. Is it divisible by 2 power 3? 8? No. 28 is not divisible by 8. So the maximum power of the prime factor 2 shall be 2 here in 2. Now is 28 divisible by 3? No. So leave that. Next prime number here is 5. Is 28 divisible by 5? No. Next prime number after that, 7. Is 28 divisible by 7? Yes. But then is 28 divisible by 7 square? Well, 7 square is 49. It is a number greater than 20. So 28 will consist of only one power of 7. Look at the other number, 108. Divisible by 2? Yes. Divisible by 4? The next power of 2? Well, divisible by 2, divisible by 4, that is 2 square. Is it divisible by 8? 8 ones are 8, 28 remaining. No, 28 is not divisible by 8. So this is gone. So maximum power of 2 here can be 2. So 2 into 2 is what we will get here, which is 2 square. Now is 108 divisible by 3? Yes. Is it divisible by the next power of 3? Yes. 108. 1 plus 0 plus 8 works out to be 9. So it is divisible by 9. Is it divisible by the next power of 3? That is 27. Yes. 27 into 4. Is it divisible by 3 power 4? That is 81. No. 108 is not divisible by 81. So the highest power of 3 that we can get here is 3. Next. Is it divisible by 5? No. Divisible by 7? No. Divisible by 11? No. So that means it is 4 into 27. That is what is 108. Next number given to us is 105. Divisible by 2? The first prime number? No. Divisible by 3? Yes. Because 1 plus 0 plus 5 equals 6, which is divisible by 3. Then is it divisible by 3 power 2, that is 9? No. Because 1 plus 0 plus 5 is 6, which is not divisible by 9. So there is only one power of 3 here. Then next prime factor is 5. Is it divisible by 5? Yes, very much. Because 5 is given to us in the units place. Is it divisible by second power of 5, that is 25? No, it is not. So we get only one power of 5 here. Next number is 7. Is 105 divisible by 7? Yes. 105 divided by 7. 7 ones are 7. 35. So 7 fives are 35. Yes. So one power of 7. As it is 3 into 5 is 15. 15 sevens are 105. Now we will take the highest power for each of the prime factors. Now take the highest power of each prime factor. So LCM here will be equal to, first prime factor is 2. What are the powers of 2 here? Here it is 1, here it is 2, here it is 2. Here we do not have 2 at all as a prime factor of 105 because 105 is an odd number, not divisible by 2. So obviously the highest power of 2 here is 2 given in these two. Next is 3. We have 3 power 2 here, do not have 3 here. We have 3 power 3 here and 3 power 1. So 3 power 1, 3 power 2, 3 power 3, highest power is 3, which is given to us here. So 3 cube. Then do we have a 5? We don't have 5 here, we don't have 5 here, we don't have 5 here. Yes, we do have 5 here. So the highest power of 5 here is 1 only. Then do we have 7? We have 7 power 1, 7 power 1, only 2 places, and the highest power of 7 here, which is being used, is 1. So this is our LCM. Now as I told you, now combine single 2 with single 5 and rewrite this as 2 into 3 cube into 7 into 5 into 2. Now 5 into 2 we have separated because this amounts to 10. Now whatever is the result obtained here by multiplying 2 with 3 cube and 7, we will just put 1 0 ahead of that. So this becomes 2 into 27 into 7 into 10. That is 54 into 7 or let us say 70. So 7 4s are 28, 7 5s are 35 plus 2, 37. So 3780 is the LCM of these given numbers. This is the least common multiple of these four numbers which are given to you in the question. Now look at this question, which has been asked in umpteen number of examinations, including CSAT. The traffic signal lights on three separate roads change after 48 seconds, 72 seconds and 108 seconds. If all the three change at the same time at 8:20, then at what time will they again change together? They all will again change together at a common time. And we want the next common time, which means we want the least common multiple of these three numbers or these three intervals of time in which each of these three lights will change. So we have to take LCM of 48, 72 and 108. So let us start with prime factorization. 48, highest power of 2 with which 48 is divisible. It is divisible by 2, it is divisible by 4, it is divisible by 8. 8 6 are 48, which means it is divisible by 16 also. So 16 3s are, so 2 raised to 4 into 3 raised to 1. 72 divisible by 8 but not divisible by 16. So as it is, we know it is 8 into 9. So this shall become 8 is 2 cube and 9 is 3 square. 108, you know that 12 into 9 is 108. So you can definitely break this up. So 12 we know is 4 into 3. So it is 2 square into 3. And 9 we know is 3 square. So this becomes combined together 3 cube. So 108 is 2 square into 3 cube. Now let us take the highest powers. The highest power of 2 here is 4, 3, 2. So highest is 2 power 4. So 2 power 4 is what we get here. Highest power of 3, 1, 2, 3. So highest power of 3 here is 3 only, that is 3 cube. Now what you can do here is split this 2 as 2 into 2 cube. Why? Because this is 2 cube, this is 3 cube. So 2 into 2 cube into 3 cube is what we will get here. This is for the ease of calculation. So this is 2 into 3 whole cube. That is 2 into 6 cube. And 6 cube you know is 216. Double of which is 432. So all these lights will change together again after 432 seconds. But then, because the time which is given to you here is in hours, minutes and seconds, you have to change 432 seconds into minutes, because obviously you can't change it into hours. So 432 when divided by 60 will give you the minutes and seconds. So 6 7s are 42, remainder is 12. So this 432 seconds is also equal to 7 minutes and 12 seconds. So that means the next time when these lights will all change together will be 7 minutes and 12 seconds after 8:20. That is 8:27. 8 hours, that is 8 hours, 27 minutes and 12 seconds. That should be the first occasion after 8:20 when all these lights will change together. Now find out the largest 4-digit number which is completely divisible by 12, 15, 18 and 27. So we will take LCM of 12, 15, 18 and 27. So 12, 15, 18, 27. Let's prime factorize this. So this is 4 3s are 12. So 2 square into 3 power 1. 3 power 1 into 5 power 1. 3 5s are 15. 18 is divisible by 9. So it is 2 power 1 into 3 power 2. That is 2 into 9. And 27 itself is 3 cube. So when you take the LCM, you take the highest power. Highest power of 2 is 2 here and 1 here. So 2. So 2 power 2. Highest power we will take here. This will come here. Then highest power of 3 3 power 1, 3 power 1, 3 power 2, 3 power 3. So this shall come here. That is 3 power 3. Into 5 is mentioned only once, and the highest power of 5 here is 1. So this shall become 2 into 3 cube is 27 into 5 into 2. See, one time 2 we are taking separately and multiplying it with 5 to get 10. So 2 into 27 is 54 and 5 into 2 is 10. So the LCM of these four numbers is 540. But look at the question. The question is asking about largest 4-digit number. Now first of all, which is the largest 4-digit number? Well, it is 9999. So simply we will divide 9999 by 540. Why? Because 540 is the least common multiple of all these four numbers. So hence every multiple of 540 will be divisible by each of these four numbers. As 540 is divisible by each of the four numbers, hence every multiple of 540 will be divisible by each of these four numbers. So 540 into 1, you have 540 here, reducing, subtracting, we get 459, so 4599. Goes by 8, 8 zeros are, 8 fours are 32, 3 remaining. 8 fives are 40, carryover was 3, so 4320. Remainder is 9 here, 7 here and 2 here. So this 279 is the remainder, which is extra amount out of 9999. So simply we will reduce this or subtract this 279 from 9999. 9 minus 9 is 0, 9 minus 7 is 2, 9 minus 2 is 7 and we get a 9 here. So 9720 is the largest 4-digit number which is completely divisible by the given four numbers. Now one thing which should obviously strike to you is that the LCM is 540 and this number, that is the highest 4-digit number, must be divisible by 540. That means in the units place there should be a 0. So out of the choices, any choice which does not have 0 in its units place cannot be your answer. So that ways you can eliminate choices also. So 9720 becomes your answer here. Now this question says find out the smallest number which when divided by 20, 25, 35, 40 leaves respective remainders of 14, 19, 29 and 34. These should be the respective remainders. By that, it means the smallest number when divided by 20, remainder should be 14. So when you say that these are the dividers and these are the remainders, when you divide by 20, remainder is 14. When you divide by 25, remainder will be 19. When you divide by 35, remainder shall be 29. And when you divide by 40, the remainder should be 34. Now a careful look will show you that 20 minus 14 is 6, 25 minus 19 is 6, 35 minus 29 is 6, 40 minus 34 is 6. So what is this? This is divider minus remainder. This we will name as D, that is a difference between the divider and the remainder. So this works out to be the same here as you can see. So required number here shall be LCM of these four quantities from which you will subtract this D. So in short, this becomes LCM of A, B, C, D minus the difference D here. So let us take the LCM here now. 20 is 4 into 5. 25 we know is 5 square. 35 is 5 into 7. And 40 is 8 into 5. So 2 cube into 5. So the highest power, 2 power cube, 2 power 3 we have here. 5 square we have taken here. And then 7 we are taking here. Now this can be rewritten as 2 into 7 into, well, here we have 5 square, that is 25. We will multiply it with 2 square, that is 4. So 4 into 25 we know is 100. So this shall be 2 square into 5 square. That is what is 100. So keep it separate, because at the end you just need to attach 2 zeros on the right hand side of the result obtained here. The result obtained here is 14. And from here we will just attach 2 zeros on the right hand side of 14. So the number that you get here is 1400. Otherwise, this calculation will become 8 into 25 into 7. See, this will become so difficult as compared to 2 into 7 is 14, and in front of that 2 zeros, 1400. As simple as that. Now the required number shall be LCM of A, B, C, D minus the difference. And difference given to us here is 6. So the desired number is 1400 minus 6, that is 1394. So this number 1394 when divided by 20 leaves a remainder 14, when divided by 25 leaves a remainder 19, and so on. Now find out the smallest number which when divided by 5, 6, 7, 8 leaves a remainder 3 in each division, in each case, but leaves no remainder when divided by 9. So the number should be divisible by 9. So what you will do first is take LCM of 5, 6, 7, and 8. Now 5 is 5 as it is, 6 is 2 into 3, 7 is 7, this is 5, and 8 is 2 cube. So the highest power of 2 here is 2 cube. 5 we have taken here, then we will take a 3, and then finally a 7. Now how should you rewrite it, because you have a 5 and 2 here? So let it be 5 into 2 into what is left here now. We have taken one power of 2 and combined it with 5, multiplied with 5. So 2 square into 3 into 7. Now this shall become 10 into, this is 4, 4 3s are 12, and 12 7s are 84. So the number here is 840. Now 840 is a number which is exactly divisible by each of these 4 numbers, 5, 6, 7, 8. But what do we want? We want our remainder to be 3. Now as 840 gets completely divisible by these 4 numbers, so the required number here shall be 840 plus 3, this remainder, that is 843. But you see, is it divisible by 9? Because it should leave no remainder when divided by 9. Well, 8 plus 4 plus 3 is 15, which is not divisible by 9. And we want a number which should be divisible by 9, then only it will leave no remainder. Leaving no remainder means remainder is 0. It means that the number needs to be completely divisible by 9. So this cannot be our answer. So let us take next multiple of 840. So our answer here basically should be of the order 840n plus 3, so that this number is divisible by 9. So let me take the next multiple of 840, that is 1680, 840 into 2. And now let us add 3 to it. What do we get? 1, 6, 8, 3. Now 1 plus 6 is 7 plus 8 is 15 plus 3 is 18, which is divisible by 9. Hence 1683 is that number which when divided by 5, 6, 7 and 8. Now this when divided by 5, 6, 7, 8, it leaves a remainder of 3 in each case, but is exactly divisible by 9. So likewise, if the first multiple, first LCM that you are obtaining, when you are adding the remainder to it, it is not fulfilling this condition, then we will take the next multiple of the LCM and then add the remainder to that multiple of LCM, and then we will verify whether the number obtained is divisible by 9 or not. Now let us learn the method of finding out the HCF, the highest common factor of 28 and 32. The very first method is prime factorization, as we have discussed. So let us prime factorize 28 and 32. In 28, the highest power of 2 is a square, that is 4, because it is not divisible by 8. which is 2 cube, but it is divisible by 4, which is 2 square. So 4 into 7 is what we have here, and 32 is anyhow 2 power 5. So when you try to find out the HCF of these two numbers, take the least power of the common factor. Now the factor needs to be common. In case of LCM, we considered each and every prime factor, even if it has power 1. But here, even if it has power 1 in the factorization of one of the numbers, and it may not be present as a factor of another number. But in case of HCF, we will consider only those factors which are factors of both the numbers. So here 2 is a factor of both the numbers, but 7 is a factor of 28, but not of 32. So 7 is not to be considered. Now take the least power of 2. Here we have power of 2. Here we have 2 raised to power 2, and here we have 2 raised to power 5. Least of these two is 2 square, which is equal to 4. So 4 is that highest number which will divide both 28 and 32, so as to say 4 is the HCF of 28 and 32. We can use another method which is called the continuous division method. In this, we will divide the greater number by the lesser number. So 28 and 32 goes by 1, you get 28 here. The remainder is 4. Now, the previous divisor, 28, shall get divided by this remainder, 4. 4 sevens are 28. While doing so, when you get 0 as the remainder, then the divisor in the final or the last division shall be considered as the HCF. So HCF here again works out to be 4. Now let us look at another question here, 493 and 928. Now 493 and 928, the prime factorization is going to be quite hectic. So let us make use of continuous division method. So 928 gets divided by 493, goes by 1. We get the remainder as 435. Now 493, the previous divisor becomes the dividend and gets divided by the remainder obtained here in the previous division. So 435 divides 493 goes by 1. So by 435, we get the remainder as 58. Now again, the previous divisor becomes the dividend. So this remainder, which is 58, divides the previous divisor 435, goes by 7. We get 406. Now again, we get remainder here as 29, which shall divide the previous divisor, that is 58, goes directly by 2. So hence, the last divisor, which gets you 0 as the remainder, shall be our HCF. So HCF for both these numbers is 29. Now find out the HCF of 100, 120 and 125. Now these are such kind of numbers for which prime factorization process can be adopted. Now while doing so, 100 we know is 2 square into 5 square. 120 is 4 into 3 and again 2 into 5. So this is 4 into 3 into 2 into 5, that is 10. 4 here is 2 square. So this shall become 2 square and another 2 here, so 2 cube into this 3 into this 5. That is 8 into 3, 24. 24 into 5 is 120. 125, again quite simple. 5 cube is 125. So the HCF here will be a number which is common to the prime factorization of each of these three numbers. 2 is present here, 2 is present here, but do we have 2 here? No. 2 is not a factor of 125. So we shall not consider 2 while taking the HCF. 3 is present here, but do we have 3 here as a prime factor of 100? No. It is not a factor of 100. It is not a factor of 125 also. So 3 is also ignored. Then 5 is given as a factor for 100, 5 is a factor for 120, and 5 is a factor of 125. Least power. We have powers of 2, this is power of 1 and this is power of 3. The least power here is 5 power 1. So our answer here should be 5 power 1, that is 5. So the HCF of these three numbers is 5. Now we can also solve this using continuous division. Now how should we use continuous division for three numbers? Take any two numbers. One should be bigger than the other, 120 and 100. The 100 divides 120, goes by 100. Remainder is 20. So the first divisor becomes the dividend and the first remainder becomes the second divisor. The remainder is 20. Now 20 divides 100, goes by 5 and you get a 0. So whichever divisor gives you 0 at the end is the HCF. Now HCF of 100 and 120 is 20. But still the third number is left, that is 125. So what we shall do is, we will divide this third number 125 with the HCF obtained for the first two numbers, that is 20. So goes by 6, becomes 120, remainder is 5. So 20 now becomes the dividend here. So 5 fours are 20, you get a 0 here. So ultimately 5 happens to be the HCF. So first, through continuous division method, you take the HCF of first two numbers and that HCF and then apply continuous division between the HCF obtained from the first two numbers and the third number. So HCF of first two numbers and third number. Apply continuous division method. So whichever divisor gives you 0 as a remainder shall be our HCF. So here also we get our HCF as 5. Now how do you find out the HCF of decimals? So HCF of 1.5, 0.24, 0.06, 0.036. Well, in general, the process remains the same. And that is, first, we will convert these decimals into integers. And the smallest decimal here is 0.036, which needs to be multiplied with 1000 so that we get the integer value as 36. So hence 1.5 and 0.24 also will get multiplied with 1000 to get you integer values. So the integer values obtained are 1.5 into 1000, that is 1500, 0.24 into 1000, that is 240, and 0.36 into 1000, that is 36. Now we shall take the highest common factor for these three numbers. And by employing prime factorization, you would be able to solve this pretty fast because 1500 has a 100 in it. So as it is, 2 square into 5 square is 100, into 3 into 5 is 15, so 15 into 100. Now this 5 and this 5 gets combined together, so 1500 can be prime factorized as 2 square into 5 cube into 3, given here. Now similarly 240. 240, quite simple, it is 8 into 3 into 10, 8 into 3 is 24 into 10. So this is 2 cube, this is 3, and 10 here is 2 into 5. So 2 power 1 and 2 cube get combined together. So 2 power 4 into 3 into 5 is what we get here, which is also written here. 36. 36, kindly remember it as 2 square into 3 square. It is 6 square and 6 is 2 into 3. So 2 square into 3 square. Now take the HCF of these three numbers by taking the least power of common factors. Now 2 is common to all the three. Least power is 2 square. So we get a 2 square here. 3 is common to all the three. Least power is 1. So 2 square into 3 power 1. 5 is not present here as a factor of 36. So hence 5 is not to be considered. So this is 4 into 3, which is 12. Now after getting 12, because we had multiplied these numbers by 1000, divide this by 1000 to get 0.012 as the HCF. Now if at all we are asked to find out the LCM and HCF of fractions, then how do we proceed? Well, we found out the LCM and HCF of integers, then we found out the LCM and HCF of decimal values. Now we will look at the concept of finding out the LCM and HCF of fractions, which is very, very simple. So LCM and HCF of fractions, if you want to find out LCM of fractions, Well, a fraction is P by Q form, that is numerator by denominator. So if some fractions are given to you and you are supposed to find out the LCM of fractions, then whatever you need to find out, the same thing you will find for the numerator, and the other will go to the denominator. What is other? Well, we have only two things to find out, LCM and HCF. So if you need to find out LCM of fractions, LCM of numerators by HCF of denominators. Similarly, if you need to find out HCF of fractions, HCF of numerators. Now, whatever you need to find out for the fractions, the same thing you will find out for the numerator, and the other will go to the denominator. Now, let us have a look at a question here. Find out the LCM and HCF of 1 by 3, 2 by 9, 5 by 6, 4 by 27. So, to find out the LCM, we know it is LCM of numerators by HCF of denominators. Numerators are 1, 2, 5, 4. So 1, 2, 5, 4. Find out the LCM of these. And denominators are 3, 9, 6 and 27. You have to find out the HCF of these. So 1, 2, 5, 4. Evidently, it is 5 into 4 only that you need to consider, because 2 is a factor of 4. So 5 into 4 is 20. It will be divisible by 2 also. And HCF 3, 9, 6, 27, you see that each of these numbers is divisible by 3. And that is the highest common factor. Because 3 divides 3. You can't have a number greater than 3 as a factor of 3. And if we need to find out the HCF of fractions, so HCF of numerators by LCM of denominators. So 1, 2, 5, 4, their HCF is 1, because you have prime numbers here. And 3, 9, 6, 27, the LCM is 54, because 27 is not divisible by 6, and 6 here is an even number. So obviously, the LCM should also be an even number. So the next multiple of 27 is 54, which is divisible by 6. And as it is, 54 is divisible by 27, so hence it must be divisible by the factors of 27, that is 3 and 9 as well. So this is how we find out the LCM and HCF of fractions. Now, a very important concept based on which many times questions have been asked. LCM into HCF equals first number into second number. Now, if two numbers are given to you, then this is the relationship between those two numbers. The product of their LCM and HCF will always be equal to the product of the two numbers. Now, the numbers have to be co-primes. That is, their highest common factor should be 1. So we can say LCM. Now LCM is also equal to HCF into product of co-prime factors. Now we will definitely solve question on each of these concepts, because if the factors of two numbers are co-primes, say A and B, and their HCF is H, then the two numbers will be HA and HB. So in that case, LCM into HCF equals HCF into A into HCF into B. So these two HCF will get cancelled. Now we can say LCM equals HCF, this HCF comes here, into product of the two co-primes. Now if the HCF of two numbers is 11 and their LCM is 7700. So HCF is 11, LCM is 7700. If one of the two numbers is 275, so let us say the first number here is 275 and we are supposed to find out the second number. It says find out the other number. So LCM into HCF equals the first number into the second number. You can also name them as A into B or X into Y, whichever way you're comfortable. So LCM is given to us as 7700. HCF is given to us as 11. And first number is given to us as 275, and we have to find out the second number. Now a careful look would suggest that 275 is divisible by 11. And how is that? Well, 2 plus 5 is 7. And here we are having a 7. So 7 minus 7 is 0. So let us balance these out. So let us cancel 11 and 275. So 11 2s are 22, 5 remains, 55. So 11 5s are 25. Now 77 into 100 by 25 equals the second number. Now 7700, I have opened this and written it as 77 into 100. Reason, 25 will cancel out 100 by 4 because 25 divides, because 100 is a multiple of 25. So goes by 4. So the second number here shall be 4 7s are 28. Again, 2 is carryover. 4 7s are 28 plus 2, that is 308, which becomes the answer. This is the second number. Two numbers are in the ratio 3:4 and their HCF is 4. Now find out the LCM of the two numbers. See, if the two numbers are in the ratio of 3:4, that becomes A:B. Why? Because 3:4, these two numbers are co-primes. So the first number X, let us say, happens to be HA. This is A, this is B. And that is 4 into 3, which is 12. And Y happens to be HB. That is 4 into 4 equals 16. So we already know that LCM equals HCF into product of co-primes. So we can simply say this is 4. HCF is given at 4. Product of co-primes, 3 and 4 are co-primes. So let us take 3 and 4 as A and B. So this is 4 into 12. That is 48. So as it is, we know, if we perform a check, that LCM of 12 and 16 is 48. 16 into 3, 12 into 4. Now the LCM of two numbers is given as 48. So LCM is 48. And the two numbers are in the ratio 2:3. 2:3 again are co-primes. So we know X is to Y. If these are the two numbers, they're in the ratio 2:3. That is HA is to HB. Find out the sum of the two numbers. We need to find out A plus B. So if we know that LCM equals HCF into product of co-primes, then HCF here equals LCM by the product of co-primes, which is A into B. So LCM is given to us as 48, and A and B here values are 2 and 3. So 48 by 6, which is nothing but 8. 6 8s are 48. So the value of HCF here is 8. Here also it is 8. A and B are 2 and 3. So the two numbers actually are 8 into 2, that is 16. And 8 into 3, that is 24. And 16 and 24 have their HCF as 8 because both these numbers are divisible by 8. So now sum of the two numbers shall be 16 plus 24, that is 40. The LCM of two numbers is 4107 and HCF is 37. So LCM is given to us as 4107. HCF is given to us as 37. Find out the greater value out of the two numbers. Now we know that LCM is equal to HCF into product of co-primes. These are co-primes. So this is 4107 equals 37 into A into B. So 4107 by 37 works out to be 37 into 1 is 37. 41 minus 37 is 4. 4 and 0 become 40. So 37 into 1 again 37. 40 minus 37, 3. 3 combines with 7 to give you 37. 37 ones are 37. So 4107 goes by 37 and gives us a value 111, which has to be equal to A into B. Now A into B is 111. Let us factorize these. 1 into 111. The other is 3 into 37. So let us take both the pairs here. When we take A is equal to 1 and B is equal to 111, in that case, first number HA and second number HB becomes 37 into 1 and 37 into 111. So this gives us 37 and 4107. Now if we take the second case here, that is A is equal to 3 and B equals 37, then we get 37 into 37, that is 1369, and 37 into 3, that is 111. Now, out of these, we want a greater value out of the two numbers. So let us go for this pair when we get greater value as the LCM of the two numbers. That is 4107. So the greater value out of the two numbers will be 4107. In case 4107 is not given amongst the choices, in case the fourth choice does not say none of these and 1369 is given to you amongst the choices, please go for that as the answer, because this happens to be the second highest out of the choices. But the actual answer here is 4107. If it is not given, then 1369. So that brings us to the end of the session for the topic LCM and HCF. Please do revise this and solve questions, practice to master the techniques and get acquainted with the variety of questions. We will meet again in the next discussion. Till then, I wish you all the best. Please work hard. Take care of yourself. Stay safe. Thank you so much.